Last week, we looked at how to graph a linear inequality. This week, we want to continue graphing, and we want to check to see if points are solutions. So if I want to check to see if a point is a solution, then I want to graph the region first and see if the point is in that region. Starting with question number 1, we've got the line y is less than or equal to 4x plus 4. So that means I have to start up at 4 on the y-axis and plot a point. If I have a slope of 4, or 4 over 1, that means that I'm going to travel up 4 and over 1, which is kind of off my graph. I can also go down 4, 1, 2, 3, 4, and backwards 1. Now that I have a couple points on my line, it's a solid line, since it's a less than or equal to. And if it's a less than, that means I'm going to shade underneath the line. So all the points in the shaded region and on the line would be solutions. For number 2, now I have that y is greater than negative x. So if I want to graph this line, I'm going to start off with y is equal to negative x plus 0. So I'm going to plot the point 0, 0. And now I have a slope of negative 1. So I can travel down 1, forward 1, down 1, forward 1. This line would be dotted since it's just a greater than. And since it's a greater than, I'm going to shade above the line. Now let's look at questions 3 and 4. For question number 3, we have that y is less than or equal to x plus 3. So I'm going to go ahead and start off at 3 on the y-axis, and I have a slope of 1, which is up 1 over 1, up 1 over 1. Since it's less than or equal to, it would be a solid line, and less than would be underneath. Finally, let's take a look at graphing number 4. For question number 4, we have that y is greater than or equal to 1/3 x plus 4. So I'm going to go ahead and start up at 4 on the y-axis. And if I have a slope of 1/3, I can travel up 1 and forward 3. And then I can draw my straight line in. It's a solid line since it's greater than or equal to. Greater than is above the line, so I'm going to go ahead and shade this region above the line. So now, looking at my 4 graphs and taking a look at my questions, 5, 6, 7, and 8, let's rotate this. We want to see when is each of the points a solution. So looking at my first point, the point negative 2, 2. If it's in the shaded region or on the line, then it's going to be a solution. So if I take a look at negative 2, 2 in the first problem, I plotted it. It's not a solution. It's not in the shaded region. If I take a look at negative 2, 2 on the second line, since it's on a dotted line, it's not a solution. If I take a look at negative 2, 2 in the third, it's above my line, and it's not in the shaded region, so it's not a solution. And for number 4, negative 2, 2, again, it's in the wrong location. It's not in the shaded region. So for number 5, it would be none. Now let's take a look at number 6. We want to see, is the point 3, negative 5 a solution? So let's erase some of these points here. So if I'm checking the point 3, negative 5, in the first one, 3, negative 5, it's in the shaded region. So question number 1, 3, negative 5 is a solution. Question number 2, 3, negative 5 is not in the shaded region. So it's not a solution. Number 3, 3, negative 5 is in the shaded region. So number 3 is a solution. And number 4, if I look at 3, negative 5, obviously it's way below the line, so it would not be a solution. So for number 6, only questions 1 and 3 would be satisfaction answers. Number 7 says look at the graphs and which problems has 0, 0 as a solution. That's the origin. So if my origin is in the shaded region, I want to include it. Looking at question number 1, true. 0, 0 is in the shaded region. Looking at question 2, I cannot include 0, 0 because it's a dotted line. It has to be on a solid line. Number 3, 0, 0 is in the shaded region, so I'm going to include number 3. And number 4, 0, 0 is not in the shaded region, so I'm not going to include it. Last but not least, let's look at problem number 8. If I look at the point negative 5, 6, I want to see if it's in the solution. Is it in the shaded region? So looking at negative 5, 6 in the first equation, it's way up there in the second quadrant. It doesn't fit. Negative 5, 6 for question number 2 does work. Number 3, if I take a look at negative 5, 6, it's not in the shaded region. Number 4, negative 5, 6 is in the shaded region. Now let's say that we were looking at problem number 2 and we really couldn't tell because our line wasn't exactly straight. I could also plug it in algebraically. So let's take a look at plugging in the point negative 5, 6 algebraically and see if it gives us a true statement. Remember that the first number is your x, the second number is your y. So if I have the inequality y is greater than negative x, I'm going to have that 6 is greater than a negative negative 5, and it's true, 6 is greater than 5. So we can see that algebraically it works as well.